Hello, I am Nathan Huchek, and today we were going to discuss the oxidation step for solar chemical looping reforming. This is for ATME 490 sustainable energy applications. First, we will discuss calculations for the unknown variables, and then review some plots that were generated in MATLAB. We can refer to a graph that was given to us during lecture, which shows the rate of oxidation for carbon monoxide versus time. We know that the rate of oxidation for oxygen is the same as carbon monoxide, so we can use this first equation for NCO. Delta for the oxidation step is found using MATLAB, which uses the CumTrap-Z, which is cumulative trapezoidal integration. And we know TCO and NCO, and that is how we find delta of the oxidation. Next, we know that the oxidation rate for CO2 in is 10.45 milliliters per minute times grams, and that the rate of oxidation for carbon monoxide equals RCO out. Using both of these values, we could plug in for RCO out divided by RCO in and find XCO2. The first graph is shown here, which is exactly what we saw in lecture. This is the rate of oxidation for carbon monoxide versus time, and you can see that it drops off at 200 seconds, which is when the cycle of the reactor is done. Second plot is delta versus time, and we can see that it quickly increases at around 10 seconds and then eventually maxes out at a time of 175 seconds. The last plot is XCO2 versus delta, and we can see that it is basically constant the whole time and then drops off at a delta value of 0.18. In this presentation, we went over the equations for calculating delta and XCO2 and the three graphs incorporating the values that we were finding. Thank you.